The climate will warm over the coming decades because burning coal, oil, and natural gas releases carbon dioxide, CO2, that prevents heat from escaping into space. If the world's average temperature rises more than 2 degrees Celsius, or 3.6 degrees Fahrenheit, we will cause what is officially termed dangerous interference with the climate system. How fast and how deeply do we need to cut emissions to avoid this dangerous interference? The carbon dioxide and climate calculator can help answer these questions. Let's see how it works. On the right side of the screen are 3 charts. These show yearly carbon emissions from fossil fuel in billions of tons. How much CO2 is in the atmosphere in parts per million, ppm, and the resulting increase in the Earth's temperature in degrees Fahrenheit. Right now, they show business as usual, the path we are on today. Annual carbon emissions are projected to rise nearly 4 times by the year 2100 to 29 billion tons. The amount of CO2 in the air will increase to over 1,000 ppm, and the climate will warm about 8.3 degrees Fahrenheit. We will cross the dangerous interference line in about 2045, so business as usual does not result in good outcomes for the climate and, by extension, for humanity's continued ability to survive and thrive on Earth. Let's see what it would take to avoid the business as usual outcomes. Using the slider on the left, we can adjust emissions separately for rich and poor countries. We'll first specify a ramp-down period from 2015 to 2050 for the rich countries, and cuts of 60% over that period, meaning steady emissions cuts between 2015 and 2050 to reach 40% of the 2015 value. We'll also choose a ramp-down period from 2025 to 2060 for the poor countries, and the same level of emission cuts, 60%. The green lines show the result. Annual emissions are reduced to 5 billion tons by 2100, less than the 1990 level. However, atmospheric CO2 increases to 560 ppm, and the global temperature rise is 4.9 degrees Fahrenheit, well past the level of dangerous interference. Let's try cutting more deeply and more quickly. We ramp rich countries' emissions down earlier, from 2005 to 2030, cutting emissions by 80%. We then accelerate the poor countries' emissions cuts from 2015 to 2040, and the level of their cuts to 80% as well. In this scenario, the green lines show that annual emissions at the end of the century are 2 billion tons. Atmospheric CO2 is 450 ppm, and the global average temperature rise is limited to 3.4 degrees Fahrenheit. Dangerous interference with the climate system is avoided just barely. The calculator can also show the average temperature rise in the central United States and in the interior regions of other continents. Continental interiors will warm faster than the Earth as a whole. If we change the button at the lower left from global average to central USA, we see that for the last scenario, the temperature rise in the central United States will be a little over 5 degrees. Under this scenario, the climate of Fort Collins, Colorado would come to resemble the climate of present-day Albuquerque, New Mexico. Under the business as usual scenario, the average temperature in Fort Collins would rise by a whopping 13 degrees, making its climate resemble that of present-day Dallas, Texas. Background information on the carbon dioxide and climate calculator is provided in the Details tab, including definitions, references, and assumptions. Numerical data are available by clicking on the Emissions and Climate tabs. Finally, information on the developer of the calculator, Dr. Scott Denning of Colorado State University, is provided in the About tab. It will be challenging to achieve 80% carbon emissions cuts over the time frame shown in the last scenario, and will require significant investments. This goal is within our grasp if we act quickly and decisively. Strategies could include large-scale energy conservation and efficiency programs for buildings and industry, replacement of fossil fuel power plants with wind and solar, the construction of energy-efficient mass transit systems, and using muscle power, renewable electricity, and biofuel for transportation. Thank you for watching this video. To experiment with the carbon dioxide and climate calculator on your own, visit this link.